Assalamu alaikum warahmatullahi wabarakatuh. In this video, we will learn how to solve example number second, in that first to fourth example from practice set 5.1, which are based on distance formula from the chapter Coordinate Geometry. Question number 2. Determine whether the points are collinear or not. So here points A 1 minus 3, B 2 minus 5 and C minus 4 7. So these points are collinear or not in xy plane. You have to determine using distance formula. So let this A be x1 y1, B x2 y2 and C x3 y3. Now by distance formula, distance AB, to prove the points are collinear or not, we will find distance AB, distance BC and distance AC. And if by distance formula distance AB is equal to square root of x2 minus x1 square plus y2 minus y1 square. Here ax1 y1, bx2 y2 and c x3 y3. So therefore distance AB is equal to square root of x2, that is 2, minus x1 1 bracket square plus y2 minus 5 minus y1 minus 3 bracket square. Therefore distance AB is equal to square root of 2 minus 1, that is 1 square, plus minus 5 minus into minus plus 3 square. Therefore distance AB is equal to square root of 1 square is 1 plus minus 5 plus 3 is minus 2 square. Therefore distance AB is equal to square root of 1 plus minus 2 square is 4, which is equal to root 5. Statement number first. Distance AB is equal to root 5. Now second, again by distance formula we will find distance BC. Distance by distance formula, distance BC is equal to square root of under root, here BC x2 y2 x3 y3. So here x3 minus x1 square plus y3 minus y2 square, x3 minus x2 square plus y3 minus y2 square. Distance BC, square root of x3 minus 4 and x2 2, so minus 4 minus 2 bracket square plus y3 7 minus minus 5, so 7 minus minus 5 bracket square. Therefore distance BC is equal to square root of minus 6 square plus 7 plus 5 bracket square. That is minus 6 square is equal to 36 plus 7 plus 5 12 square, which is equal to 36, here it is equal to 36 plus 144. 12 square is 144. So therefore distance BC is equal to 36 plus 144 is 180, which is equal to 180 factors of 180, 36 into 5. So distance BC is equal to 6, square root of 36 is 6 root 5 units, that is second. Distance BC is equal to 6 root 5. Now third, we will find distance AC. So by distance formula, distance AC. Distance AC is equal to under root here x1 y1 x3 y3. So x3 minus x1 square plus y3 minus y1 square. So by distance formula, with x2 x1 y1 and x3 y3, x1 x3 minus 4 minus 1 minus 4 minus 1 square plus 7 minus minus 3, 7 minus minus 3 bracket square, which is equal to square root of minus 4 minus 1 minus 4 minus 1 is minus 5 square plus 7 plus minus into minus plus 3 bracket square, which is equal to minus 5 square, that is 25 plus here 10 square. Therefore distance AC is equal to 25 plus 10 square is square of 10 is 100, which is equal to 125. Therefore square root of 125 is equal to 25 into 5, which is equal to square root of 25, that is square root of 25 is 5. So answer is 5 or root 5, statement number 3. So now from 1, 2 and 3 we get root 5 plus 5 root 5 is equal to 6 root 5. Therefore from 1, 2 and 3, 6 root 5 is equal to root 5 plus 5 root 5 from first, second and third statement, that is distance BC is equal to distance AB plus distance AC. Here A lies between B and C, B dash, C. Therefore the points are between this exist. Therefore points A, B, C are collinear points. Second example, n minus 2, 3, m 1 minus 3 and 5, 4, x1 y1, x2 y2, x3 y3. So by distance formula, distance ln is equal to square root of x2 minus x1 square plus y2 minus y1 square. Therefore distance lm is equal to under root square root of x2 1 minus 2, x1 is minus 2 bracket square plus y2 plus y2 minus y1 square. So y2 minus 3 minus 3 square. So therefore distance lm is equal to square root of 1 minus into minus plus 2 bracket square plus minus 3 is minus 6 square. So distance lm is equal to square root of 3 square plus minus 6 square is 36, which is equal to 9 plus 36, which is equal to distance lm is equal to square root of 45. Distance lm is equal to root 45. 9 plus 36 is equal to 45. Again, now second we have to find distance by distance formula. By distance formula, distance mn is equal to square root of x3 minus x2 square plus y3 minus y2 square. Mn, so distance mn is equal to square root of x3, that is 5 minus x2 1, 5 minus 1 bracket square plus y3 4 minus 3, 4 minus 3 bracket square is equal to 5 minus 1 4 square plus 4 plus 3 bracket square. That is, therefore distance mn is equal to 16 plus and square root of 16 plus 7 square, which is equal to 16 plus 49. So therefore distance mn is equal to square root of 16 plus 49 is 65, root 65, distance mn. Now third, we have to find distance by distance formula, distance ln. Distance ln is equal to square root of under root x3 minus x1 square plus y3 minus y1 square. x3 minus x1 square plus y3 minus y1 square by distance formula. Therefore, distance ln is equal to under root x3 is 5 minus x1 2 5 minus 2 bracket square plus y3 4 and y1 is 3 4 minus 3 square. Therefore, distance ln is equal to 5 minus into minus plus 2 square plus 4 minus 1, that is 1 square, which is equal to, so distance ln is equal to square root of 7 square plus 1 square is 1, which is equal to 7 square 49 plus 1, which is equal to square root of 50. Statement number 3. So from 1, 2 and 3 we get under root the greatest length, that is 65. Root 65 is not equal to root 45 plus root 50 from first, second and third. That is, distance mn is not equal to distance lm plus distance ln. So point n does not lie between m and n. Therefore, the points L, M, N are not collinear. They are not collinear points. Third example, R03, D21, 3S3 minus 1, x1, y1, x2, y2, x3, y3. So are these points collinear or not? So let us decide by distance formula. Distance RD is equal to square root of x2 minus x1 square plus y2 minus y1 square. Therefore, distance RD is equal to x2 2 minus x1 0 square plus y2 1 minus 3 square. That is, distance RD is equal to 2 minus 0 2 square and 1 minus 3 is minus 2 square. So distance RD is equal to under root 4, 2 square is 4 plus 4, that is root 8, square root of 8. Statement number first. Also by distance formula, second, by distance formula, distance ds is equal to x3 minus x2 square plus y3 minus y2 square. So distance ds is equal to square root of x3, that is 3 minus 2 square plus y3 minus 1 minus y2 is 1 square is equal to under root 3 minus 2 1 square plus minus 1 is minus 2 square. So distance ds is equal to square root of 1 square is 1 plus minus 2 square is 4, which is equal to root 5. Statement number 2. Now you have to find the distance rs. So by distance formula, third, by distance formula, distance rs is equal to square root of x3 minus x1 square plus y3 minus y1 square. So distance rs is equal to under root square root of x3 is 3 minus x1 0, 3 minus 0 square plus y3 minus 1 minus y1 is 3 square. So distance rs is equal to under root 3 minus 0, 3 square, minus 1 minus 3 is minus 4 square. Therefore distance rs is equal to under root 3 square is 9 plus 4 square is minus 4 square is 16, which is equal to square root of 25, which is equal to 5. That is statement number 3. Therefore from 1, 2 and 3, here the greatest distance is 5, that is 5 is not equal to root 8 plus root 5 from 1st, 2nd and 3rd, from 1, 2 and 3. Therefore distance rs is not equal to distance rd plus distance ds. D is not between r and s, therefore betweenness does not exist. Therefore points r, d, s are not collinear. They are not collinear points. Fourth example, p minus 2, 3, q 1, 2 and r 4, 1, x1, y1, x2, y2, x3, y3. By distance formula, distance pq is equal to square root of x2 minus x1 square plus y2 minus y1 square. Therefore distance pq is equal to square root of x2 is 1 minus x1 is minus 2 square, x1 is minus 2, y2 2 minus y1 is 3 square. Therefore distance pq is equal to square root of 1 plus 2 square, 2 minus 3, that is minus 1 square. So distance pq is equal to square root of 3, 1 plus 2 is 3 square, that is minus 1 square is 1, that is 9, 3 square is 9 plus 1, which is equal to root 10. Number 1. Again by distance formula, distance qr is equal to square root of x3 minus x2 square plus y3 minus y2 square. So distance qr is equal to x3 4 minus x2 is 1 square plus y3 is 1 minus y2 is 2 square, which is equal to 3 square plus minus 1 square. So distance qr is equal to root 3 square 9 plus 1, which is equal to 10, root 10. So qr is also root 10. Now third, distance pr. By distance formula, distance pr is equal to square root of x3 minus x1 square plus y3 minus y1 square. Therefore, distance PR is equal to under root square root of x3 4 minus x1 2, 4 minus 2 square plus y3 1 minus y1, that is 3, y1 is 3 square. Therefore, distance PR is equal to square root of 4 minus 2 will become plus, minus into minus plus 2 square, 1 minus 3 is 1 minus 3 is equal to minus 2 square. Therefore, distance PR is equal to 4 plus 2 6 square plus minus 2 square is 4, which is equal to under root 6 square 36 plus 4. Therefore, distance PR is equal to 36 plus 4 is 40. Now 40 can be written as 4 into 4 times the 40, which is equal to 2. 4 square root of 4 is 2 root 10. This is statement number 3rd. So, but now distance PQ, that is root 10, distance PQ plus distance QR is equal to distance PR, that is root 10 plus root 10 is equal to 2 root 10 from 1, 2 and 3. From first, second and third statement, the distance PQ is equal to PQ plus QR is equal to PR. Therefore, betweenness exists. Point Q lies between P and R. Therefore, points P, Q, R are collinear. They are collinear points.